Diffusion is a basic transport mechanism. In this video, I'm going to tell you what is diffusion. Hey everyone, welcome back to HM Learnings. I am Harshida, the creator of HM Learnings, where students come to clear their concept and to get the study material. Make sure you subscribe our channel. So today we are back with the part 3 of physics of gas video, and this video is about the diffusion. So if you haven't watched the previous two versions or parts of the physics of gas, you can go and watch. I'll share the link of them in the description box. So in this video, we are going to talk about the diffusion, and in the next part of this physics of gas, we are going to talk about the Fick's law, which is a law of diffusion. So what is diffusion? Diffusion is basically means that the random molecular movement of molecules. So this video is about a very basic understanding of diffusion, because diffusion is a very basic topic. It can be asked in Viva, it can be asked in theory exams as well. So if you don't know this topic, this could be a blunder for you. So you need to know the diffusion. So diffusion, if we understand what does it mean, it means the random molecular movement of molecules. Now what does it mean? It means, suppose if you take a beaker of water, okay, this is a beaker which is having water. So this water is having what? This must be having the water molecules. So the red dots are showing the water molecules. So what is diffusion? Diffusion says, or it has been seen, that the water molecules, if we talk about the one water molecule, let's say this water molecule, so this water molecule is in constant motion. So this water molecules is actually going to move continuously in all the directions randomly. So it could move in right, it could move in left, it could move up, it could move down. So random motion is there. So random motion means that it could move in any direction, and they are in the constant motion. Each water molecule is in constant motion. So constant motion doesn't mean that the velocity of a water molecule is going to be constant. No, the velocity of a molecule will change, but it is sure that the water molecules, each water molecule will be in motion always. So if we take this particular water molecule, like this water molecule is there, it has started moving towards right, and there was one more water molecule to which it stuck. So this water molecule was also in motion, this water molecule was also in motion. So as a result, what will happen? There will be change in the direction of the movement of the water molecules. So now this will start moving towards down, and this water molecule could start moving in any other direction. So there is change in direction when they strike with each other, and also there will be a change in the velocity, because velocity means that there will be change in the direction as well as there will be change in the speed at which they are moving. So both will be both direction and speed will be changed. So now this water molecule could collide with the other water molecule, further lead to the change of both the velocity, both the direction and the speed of the molecules, and this is what is called as the diffusion. So it means the random molecular movement of molecules. So this diagram is also showing the same thing. I'll erase the ink on the slide. So you can see that this red dots are the molecules of a matter. Suppose it is a gas or a water molecule, and now one molecule they have traced down, and they trace the path of that molecule, that when it strikes with the other water molecule, with other molecules of a matter, it can move in any other direction, it can move with other speed, and ultimately it shows a random movement which is being there. So almost 1,000 times per second it has shown the bouncing in all the possible directions, and that is how this is termed as a random molecular movement. So now I hope that you understand that diffusion basically means the motion of the molecules of a matter in any direction, in any random direction. All the molecules will be in motion, but the velocity will vary as they collide with the other molecules. So now is it what kind of matter is exerting, what kind of molecules are exerting the motion? Is it only the free molecules of gas, or the free molecules of liquid, or is it solid also exerts the diffusion or not? Or is it like that if you dissolve NaCl in water, or if you dissolve oxygen in water, will it exert diffusion? The answer is yes. Free molecules of gas, free molecules of solid, free molecules of liquid, all of them exert the diffusion. The rate of the diffusion, the speed of the diffusion could vary. The dissolved ions, that is, suppose NaCl dissolved in water, NaCl will exert the diffusion, and water molecules will also exert the diffusion. Dissolved gases like oxygen in water will also exert diffusion. Water molecules will also exert the diffusion. No matter what is your state of matter, no matter which no matter which phase is being dissolved in which other phase of matter, all of them is going to exert the diffusion. All the molecules is going to exert the diffusion. And what is diffusion? It is a random molecular movement of the molecules. That is diffusion. Now, where does the energy came from? So we are saying that this is in motion. So molecules are in motion. So that means they are having the kinetic energy. So yes, the source of energy of the motion to exert is the kinetic energy, and this energy is coming from is basically because of the temperature, and that is by the term as the thermal energy. So any water molecule, if it is at the room temperature, or at lesser than room temperature, or higher than room temperature, the energy it gets is from the atmosphere by the temperature, and that is how it is having a kinetic energy. So it will start moving. So all the water molecules start moving in all the random directions, bouncing with each other. Now, higher the temperature, the greater will be the motion, because higher the temperature, higher will be the kinetic energy, higher will be the bouncing, and then higher will be the motion. So at absolute zero temperature, as there is no source of energy for the molecules, there will be no motion which is going to happen. So there will be no diffusion which could occur, which could happen at the absolute zero temperature. So from this slide, I hope it is clear what is diffusion to you. Now this is, we have taken a space, a closed space we have taken. Suppose this is a beaker only in which the water molecules are being there, and they are having the motion in all the possible directions. Now suppose you are standing, you are in a closed space only. This is a room. Suppose you are standing here at one corner of the motion one corner of the room, and someone is suppose cooking something here, okay, and you can see that the cooking leads to the smell of the food, and that smell of the food is now, after some time, after a few seconds, it will come to you. Okay, so this is what? This is also the movement of the molecules, which is happening from one side to the another side. Okay, so movement of which molecules? The molecules of gas, of course, because the medium here is the gas. So the molecules of gas are moving from one direction to the other direction. So even though we are saying that the motion is happening in random direction, but still if you talk about the net direction, there is some net direction. So net direction means that if I'm saying that, okay, after 1 second, so I have given 1 second for all the molecules to move, and after 1 second I'm just trying to calculate what is the net direction in which they have moved. So what is that net direction, and how does the net direction is being decided in the case of the diffusion? That is the next question. So now suppose you're having two sides. This is a barrier. Suppose this barrier is not at all, it is not acting as a barrier. This is just a barrier, this is just a space. Okay, this is just a barrier which is separating the two spaces. So you are having side A and you are having side B, which are separated from each other by a barrier, and this barrier is not allowing the gas molecules to move from here to here or here to here. It is not allowing any kind of mixing. Now you are having some molecules of the same gas here and some molecules of some gas here. Okay, now what you have done, you have actually opened this barrier. Okay, so you have opened the barrier, you made a small gate in this barrier and you opened this barrier. Now the question is, these are X molecules, these molecules are termed as X molecules. Now the question came, the first question, how will you know that whether the X molecules will move or not? Whether the X molecules will move or not. The second question came, if they move, what will be the direction of movement? Whether they will move from A to B or from B to A. And next thing, if I give them 1 minute to move, what will be the net direction of movement? Whether the net direction is A to B or B to A. So how does these things are going to be decided? So although these molecules, when your barrier is closed, these molecules are going to exert the random motion. They're exerting the diffusion. They're exerting the motion in all the random directions. Similarly here. But if you open this barrier, open this gate of the barrier, what will happen? Whether they will move from here to here or not, or if they move, in which direction they will move. So the answer to this question can be given by something called as the electrochemical potential of X. So we are talking about the X molecule. So what is the factor which is going to decide that whether the X molecules will move or not? That factor is termed as the electrochemical potential of X across a barrier. So electrochemical potential means it has two components, electrical potential and chemical potential. Electrical potential, suppose if your X is charged, it could be a cation, it could be anion. And chemical potential is what is the concentration of X at site A and concentration of X at site B. So these factors are going to decide that whether the X molecules will move or not. So suppose if you define what is electrical potential, so suppose your X molecules are the cation. Okay, so cation molecules were more, the site A was more positively charged as compared to site B. Okay, so there is electrical gradient here because they were not equally charged. The site A is more positively charged than the site B. So there is electrical potential here. Chemical potential means that there were more number of X molecules. Okay, so if I erase it to give you more better understanding. Okay. So your concentration gradient means that number of X molecules at A is suppose C1 and number of X molecules at B is suppose C2. So we are saying that C1 is not equal to C2. This is again a concentration gradient, that there is a difference in terms of how many molecules of X are present at site A and how many molecules are present at site B. So there is a chemical potential difference or a concentration gradient between site A and site B across barrier. Again, electrical potential is what? That there were more positive charges at site A as compared to the site B. Now for this example, you consider that the X molecules are the uncharged molecules. So uncharged molecules like gas molecules, oxygen, carbon dioxide. So in that case, what will happen? The electrical potential has no role here because there is no charge. So that means whether the oxygen molecules are present site A or site B, the potential is going to be zero at both the sides. The electrical potential is going to be zero on both the sides. So electrical potential is not a deciding factor when the X molecules are uncharged molecules, and we have considered that the X molecules are here the uncharged molecules. So again, the barrier is there, the site A is there and site B is there, and there are molecules which are present here. So whether the X molecules will move or not will be decided by the one factor here, which is the concentration gradient. So if the concentration gradient is 0, in that case, no movement will happen. No net movement will happen if you open the gate. So no net movement means what? It means that when the barrier is open, they are exerting the random motion. So by that motion, it is possible that some molecules from site A will go to site B and some molecules from site B will come to the site A. But overall, when I see at end of some time, there will be no net movement because the number of X molecules at site A and number of X molecules at site B both were equal. So that is how there will be no net movement at all. So but if the concentration gradient is there, so suppose we are saying that yes, there is a concentration gradient across barrier. Okay, so site A is suppose having more X molecules than site B. In that case, the concentration gradient is there. So yes, the movement will happen. So from where to where it will happen? From site A to site B, where it will happen. So yes, the X molecules will move across a barrier if a concentration gradient is there. How will they will move? They will move in both the directions. So even though the X molecules are more on the site A as compared to the site B, still the X molecules will move into both the directions, as I said in previously, because here the molecules also are in the random motion, here the molecules are also in the random motion. So when the gate is opened, what will happen? Because of the random motion, some of the molecules could go from here to site B to site A and site A to site B. So molecules will move in both the direction, but the net movement will be from high concentration area to the lower concentration area. So that means if we are saying that site A is having more X molecules as compared to the site B, ultimately the movement will happen from site A to site B. That will be the net direction of movement. Okay, so we have understood what is diffusion. It is a random molecular movement of the gas molecules. Then we have seen that okay, it is a random movement of molecules, but after, like, if we give some duration for the gas molecules, for any molecules to be there, and there is some concentration gradient if you're talking about the gas molecules, the uncharged molecules, because there the electrical potential is zero. In that case, the movement will happen from high concentration to the low concentration. This is also showing you the same thing, that if you are having a beaker, if you're having water or any other solvent in which the gas molecules are dissolved, site A is having the more air molecules, more gas molecules, and site B is having the less molecules. So ultimately, in both the directions, the diffusion, the movement of the molecules are happening, because you know already that the molecules are showing the random motion, so they will move in all the directions, but the net movement will be decided by the concentration gradient, and it will happen from a high concentration to low concentration. Okay, this is what the diffusion is. Now the next question comes, what will be the rate of the diffusion? Like how many molecules per unit time will move from site A to site B? And if they move, at what time the diffusion will come to an end? Now these questions are going to be answered by the law which is called as a Fick's law. Okay, so in the next video we are going to talk about what is Fick's law. So if you like this video, and these are the references you can look up to for diffusion, they have explained very nicely what is diffusion. So if you like this video, please like, share and comment down your suggestions for the upcoming videos. Till then, keep learning.